From the smallest bolts to the largest skyscrapers, our world depends on steel. In one way or another, all modern technology depends on steel because of its strength, versatility, and economy. Steel, the strong and durable keystone of modern technology. Steel, common name for 1,000 different alloys serving an incredible range of uses. Common name for new ferrous metals, which are constantly being formulated to meet changing needs and new demands. New uses, new requirements for today's world and tomorrow's. Call for a steel-making specialist. Lukens Steel Company, specialist for tomorrow. Specialist in plate steels, for nuclear reactors, for huge generators required to meet growing demands for electrical energy, and for the structures to carry that energy to the nation's towns and cities. Plate steels for the refineries of America, for the ships, the trains, and the trucks that transport the products of these refineries to all parts of the country. Plate steels for the high-rise buildings that alter our metropolitan skylines, creating usable space in midair. Plate steels, steels for the behemoths of the construction industry, the extrusion molds of the plastics manufacturers, and for hundreds of other industrial uses. Lukens produces custom-crafted plate steels and plate steel shapes to meet a vast range of requirements. These are just a few examples of how today's world is using specially produced plate steels. Tomorrow's requirements will increasingly challenge the industry's versatility, flexibility, and inventiveness. And meeting this challenge is a way of life at Lukens Steel, where the only things we make are plate steels and plate steel products. Over the years, Lukens has been an industry leader in plate steel development and research. This leadership has allowed us to maintain our reputation as the company capable of finding solutions to problems in the production and application of plate steels. At Lukens, we think that's an important part of doing business. The company is committed to keeping pace with the ever-changing demands tomorrow's world will bring. And of course, that includes making steels in step with science. Lukens' specially developed LT75 plate steel is being used for large offshore oil rigs in the Alaskan oil field, where it must withstand 30-foot tides and 7-foot thick ice flows at extremely low temperatures. Lukens' plate steel production process begins with the purchase of quality raw materials. Our buyers consider both the chemical composition and the physical form when buying recyclable steels. Raw materials are spectrographically sampled when they arrive and segregated according to type for storage. These are the raw materials that go into the making of Lukens plate steels. Following clearly defined and precisely calculated directions, a weigher sees that just the right mix of raw materials in the proper weights are loaded into the buckets to be charged into the furnaces of the electric melt shop. The power is turned on, and under the watchful eye of the melter and his first helper, the electrodes begin their descent into the furnace, melting the raw materials with the intense heat of their art. In its melting operations, Lukens Steel uses a computerized operator guide control system, which is one of the most advanced applications of computers to electric furnace melting. The operator guide control monitors and records the progress of the heat. It instantaneously calculates the actions required and constantly guides the furnace operator in the performance of operations to assure the highest degree of melting efficiency and product consistency. Once the raw materials are melted and the temperature of the molten steel reaches approximately 2,800 degrees Fahrenheit, a sample is taken and sent to the chemical laboratory in the melt shop, where within minutes, the precise chemical content is determined and fed into the computer. Based on the test results, the furnace operator may increase the temperature of the heat, add alloys in exacting quantities, and take further test samples. An electric furnace can generate large quantities of dust. But as far back as the early 1950s, Lukens undertook important projects designed to prevent environmental damage. A specially designed Lukens system collects this dust from the air. The system is remarkably efficient, even though it must operate under extreme temperature conditions. When the heat is ready, the furnace's tap hole is opened. The furnace is tilted. And the molten steel, approximately 2,900 degrees Fahrenheit, pours into a ladle. Certain types of steel, intended for specialty applications, may undergo a purifying process known as vacuum degassing while still in the molten state. By exposing large surface areas of the fluid metal to a vacuum in the treatment chamber, this process quickly and efficiently removes gases such as hydrogen and oxygen, and by its mixing action results in chemical and temperature uniformity throughout the steels. The operation is monitored and controlled by the operator at the control console. Recording gauges, meters, and signal lights keep him informed of the condition of the equipment and the progress of the treatment. During the melting process, molds are readied on specially designed pouring cars in the nearby mold preparation building. To achieve better surface and internal quality in its ingots, Lukens uses the bottom pouring practice. A center runner is set onto the bottom plate to receive the molten metal and direct it to hollow refractory bricks, which will carry the molten metal to the bottom of each ingot mold. In the electric melt shop, the ladleman maintains control of all phases of the teaming operation. After proper cooling, the string of mold cars is moved to the stripper building, where this stripper crane, one of the world's largest, removes the molds from the ingots and places the ingots on cars for delivery to one of Lukens' rolling mill complexes. Not all of Lukens' plate steels emerge from the electric melt shop in the form of ingots. In some cases, an entire heat of steel is cast directly into a slab strand, as thick as 12 inches, 85 inches wide, and as much as 100 feet long at the company's strand or continuous casting facility. The molten steel is poured into a ladle in the conventional manner, but there the similarity ends. Placed onto a transfer car, the brimming ladle is moved to the strand casting building, stopping first at an argon stirring station. Here, This inert gas is bubbled through the molten steel to ensure complete chemical homogeneity and precise temperature control. The ladle, which with its contents weighs 200 tons, is lifted more than 40 feet to the casting floor by a remote-controlled crane. The operator positions the ladle above the preheated tun dish, into which is poured a reservoir of hot metal in preparation for the cast. Since the operation's success depends upon precise temperature control, the molten metal must be checked in the tun dish before the controlled flow of liquid steel enters the oscillating mold under the watchful eye of the #1 operator. The outer shell of the slab is formed in the spray chamber, where 725 gallons of water a minute are sprayed in predetermined patterns to assure uniform solidification. Next, the strand of steel passes through a series of rolls in a curve, where it becomes solid, and then through straightening rolls before emerging as a slab. The piercing flames of 2 torches cut their way through the strand to cut the precise slab size for rolling to a plate that fills the customer's order. The water cooling systems in Lukens' electric melt shop complex are all of a closed-loop nature, which means that once the water is used and heated, it is circulated through cooling towers and then reused. Small amounts of water are occasionally drawn into the system to replace that lost through evaporation. Whether slabs or ingots, before the now solid steel can be rolled into plates, it must be softened again by heating in one of Lukens' natural gas-fired soaking pits. Here, slabs and ingots are literally bathed in heat at temperatures over 2,300 degrees. Some ingots are heated for as few as 6 hours, while others must remain in the fiery pits for up to 20 hours. When an ingot is ready for rolling, it is lifted from the pit by huge tongs and carried to a waiting ingot buggy, which transports the glowing steel to the rolling mill. It is on the rolling mill that the ingot or slab completes its evolution into steel plate. It is reduced in thickness and increased in length and width as it passes back and forth through the mill rolls. Lukens' modern 140-inch mill can be operated either as a slabbing and roughing mill to break down ingots for rolling to wide plates on Lukens' 206-inch mill, or as a finishing mill for the production of plates from 3/8 to 10 inches thick and in weights up to 30 tons. From their air-conditioned pulpit, the mill and table operators, aided by closed-circuit television, control the movement of the steel and the operation of the vertical and horizontal mill rolls. This mill can reduce carbon steel ingots and slabs as much as 2 inches in a single pass between rolls, which exert up to 9 million pounds of pressure on the glowing steel. High-pressure water sprays at the mills and in the descaling box ahead of it loosen the scale that has formed during heating, and a detached vertical mill with upright rolls reduces the width of the material and sets a square edge on slabs and plates. Before the steel leaves the mill table, its thickness dimension is checked by a gauger, and the identifying mill number is stamped on the material. The 206-inch rolling mill was the first in the United States to employ 2 large backing rolls to reinforce the smaller working rolls. Plates produced on this mill range up to 25 inches in thickness and have been produced in weights which have exceeded 40 tons. Water used in cooling and descaling operations at the rolling mills collects oil from the mills and iron oxide from the steel plates. This water is cleaned and either recycled or piped to several settling basins where impurities are removed. Some plate steels undergo special heat treatment in order to best develop their hardness or strength. This is particularly true of plates to be used in high-temperature applications such as hydrocracking vessels in the petroleum industry, where temperatures reach 900 degrees Fahrenheit, and steels to be used in low-temperature applications like the storage of liquid natural gas at 260 degrees below zero. A continuous natural gas-fired furnace line, the length of 2 football fields, is used to quench and temper or to normalize specific plates. This facility and its auxiliary cars and tables are controlled from a central pulpit. Because of their size, some plates and plate shapes, like this steam generator cap intended for an atomic power plant, must be heat treated in cavernous car bottom furnaces and quenched in a huge floor tank. Before plates are shipped to customers, test pieces are cut from material for analysis at the metallurgical laboratory. Here, test samples are received from the various departments and prepared for different tests to determine the steel plate's properties. Some of the testing equipment was developed here at Lukens. If the plate meets the required test standards, it is gas cut or sheared to the ordered size. Plates may be transformed into special order shapes by cutting torches using a jet of white heat created by burning natural gas with oxygen. Using a multiple torch machine guided by a template and an electric eye, a Lukens craftsman can cut several identical shapes simultaneously. Some plates may be pressed, stamped, sheared, or otherwise formed to the shapes required by our fabrication customers. This 1,000-ton stamping press completes the process from plate to product with minimum of handling by the operator and his crew. Elsewhere in Lukens fabrication facilities, a crew using heavy bending rolls forms a hot 6-inch thick, 22-foot long plate into a half cylinder with a precision that comes from experience. Yet another line of Lukens plate is clad steel. In this field, Lukens is a pioneer. A clad steel plate is actually a composite plate made up of 2 different metals. These are cut to exacting dimensions, specially prepared and cleaned before being assembled into a pack. A parting compound is applied between the 2 alloy plates, which face each other in the dual pack to prevent them from being bonded together in the rolling operation. The pack is welded shut and rolled on the mill to achieve plates of the ordered size. The rolling process also joins the alloy plates to their backing material. When completed, the pack is cut open and the 2 clad plates are separated. Lukens plates and plate shapes sometimes require special surface finishes. For this purpose, Lukens operates polishing equipment. Surface blasters, and a mechanized production line specially built to finish solid stainless and clad plates up to 50 feet long and 1.5 inches thick. Still other plates are made into pressed or spun plate steel heads. These dome-shaped plates are commonly used for the heads of pressure vessels in the petroleum and chemical industries, for the storage of everything from municipal water to liquid oxygen, and for the end heads of nuclear reactors, pressurizers, and steam generators, like this one being formed for a nuclear power plant. Lukens was the first company in America to form heads in this manner. That was in 1885. Today, Lukens leads the industry in this specialty. We produce heads up to 29 tons in weight and 8 inches in thickness. The largest heads manufactured here are 260 inches in diameter. At the heart of this crew is the flanger. He has the critical responsibility in directing the machine operator in the forming of the head. Up to 5 reheatings, followed by successive spinnings, may be necessary on large heads before they are formed to final size. Lukens has developed about 4,000 varied head types, some of them unique to meet the demands of the nation's industrial growth. Lukens' present position as the world's leading producer of specialty carbon, alloy, and clad steel plates, heads, and plate shapes is due to the continuing application of this commitment. It's quite a challenge to be the specialist in plate steel production, because in this rapidly changing field, what was unusual yesterday becomes the normal tomorrow. There's very little business as usual. At the very heart of Lukens plate steel production are constant modernization and research, meticulous attention to quality, and a large measure of good old-fashioned pride in what we do. All of these elements taken together uniquely prepare Lukens for maximum participation in tomorrow's world. A world of increasingly diverse needs for plate steel. A growing market for carbon, alloy, electrifying, and clad steel plate. For machinery. For power generating. For shipbuilding. For construction. And for 100 other uses. Lukens Steel. Specialist for tomorrow.